Hello everyone. What we're going to do now is we're going to be starting our next section, section 4.1. And for those of you that have not enjoyed the last few sections, I have a feeling that section 4.1 is going to be quite a enjoyment for you because we're actually going to change up now. So for those of you that are more algebraic minded, this section is for you. Okay, if you remember in section 2.5 on the very last few pages there, we mentioned something called the fundamental identities. Okay, so you want to go back and look at those um, because now as we start section 4.1, we're going to take the fundamental identities and we're actually going to apply them. Now, the fundamental identities will be the ones on page 228 and 229 in your book. They're going to be in pink there in your book. Now, you don't have to memorize those. I will give those to you. What you want to be expecting in terms of a formula sheet for the exam, for the midterm, is you want to be expecting something like the card in the front of your book, except mainly it's just going to have any form that the card in your front of the book has more than I'm going to give you. It's just going to have formulas and it's going to have identities. That's basically what I will give you for the test. The card in the front of the book gives you unit circles and the reference triangles. I'm going to expect you to know the unit circle. I'm going to expect you to know the reference triangles. But any kind of formula or identity that you need to use, I will give to you. Okay? So keep that in mind. It will be attached to the test, so there's no reason for you to feel like you need to bring one. Okay? So they will give it to you at the ICC Testing Center. So now on to fundamental identities. We're going to do a few applications of it first, and then we'll actually do some verifications. Verifications of identities is what Chapter 4 is going to be about. And this is probably one of the most important chapters in the book, okay? So you're going to need to make sure you know how to do this. So let's just say, for example, let's just say that cosine of x equals negative 4/5. Okay? And that tangent x equals 3/4. And the directions would say something like find the other trig functions. Find the other trig functions. Okay? Now, before we had to do this a more complicated way, identities are going to help you with this. Because first and foremost, let's get these out of the way. We can get secant x very easily because we know secant is the reciprocal of cosine. That's the reciprocal identity. That's one of your identities. Secant is 1 over cosine. So it's just the reciprocal. So we know that secant is going to be negative 5/4. Cotangent, on the other hand, is the reciprocal of tangent, 1 over tangent. So it's going to be 4/3. Okay, so we've got 4 of the 6 already. Okay, so we just have to find sine and cosecant. And that's where before you had to go through some complicated measures using r squared and all those different things to try to figure this out. But now that we know reciprocal identities, we can make this a little easier. Because think of it this way. This is one of your identities. Tangent x equals sine x over cosine x. Tangent x equals sine x over cosine x. Well, we know tangent and cosine, and we're trying to find sine. Because if we know sine, we can get cosecant. So solve this for sine x, and so if I solve that equation for sine x, I get cosine x times tangent x. Alright, so at this point, we know what cosine is. Look, we were given that. We know what tangent is. We were given that. So we can put this in the problem. So I have a negative 4/5 times 3/4. So multiply those together and you get negative 3/5. So that's sine x. So we found the fifth trig function. Well, we only have one more to go, and that's cosecant. And remember, cosecant is the reciprocal of sine, so it's 1 over sine. So that's going to be negative 5/3. So see how easy, if you know some identities, how easy it makes finding all these trig functions that were so difficult to find in the past. Okay? So that's one way I could ask you a problem like that. Alright? Another way would be like this. If I said, if I told you cosine of x equals negative 4 over the square root of 17, and tangent x is less than 0. Find the exact values of all the trig functions. Well, we know cosine, so we automatically know secant. So secant would be the negative square root of 17 over 4. That's not a problem. That's just a reciprocal. Okay? Now, the rest of them is where it gets a little dicey. Okay? So, basically, in order to find, we already know cosine, so in order to find the rest of these, we need to figure out what sine is, because we can use sine to get cosecant, and we can use sine and cosine to get tangent, and then use tangent to get cotangent. You see what I'm saying? So we need to, sine and cosine can help relate things a lot of times because they are so interspersed and related themselves. So what you have to do is figure out what fundamental identity relates both sine and cosine. Well, it's going to be this one, and it's called the Pythagorean identity. Okay? Sine squared x plus cosine squared x equals 1. Sine squared x plus cosine squared x equals 1. So, if you solve this for sine x, you're going to get sine x equals plus or minus the square root of 1 minus cosine squared x if you solve it for sine x. Okay? Just like you would if you were solving a Pythagorean theorem problem. Okay? Same kind of deal there. Now, which one is it? Notice we have two answers here. We have a positive square root of 1 minus cosine squared x and a negative square root of 1 minus cosine squared x. Well, here's the answers in the details. Look up here. Cosine. Cosine is negative. It's a negative 4. Tangent is negative. Where are both cosine and tangent negative? Where are both cosine and tangent negative? Okay, well, cosine, we know cosine is the x value. Cosine is negative on the left side of our graph, left side of our circle. So that would be either quadrant 2 or quadrant 3. And we know tangent is negative. Tangent is sine over cosine in quadrant 2. So quadrant 2 is where this is located. And so because of this, we know that what is sine in quadrant 2? In quadrant 2, the value of sine is always positive. So we're going to use the positive version of this instead of the negative version. So let me go through that again. Excuse me. Cosine is negative in quadrant 2 and quadrant 3. Tangent is negative. Out of those two, tangent is only negative in quadrant. Because see, look, let me draw this. This may help explain it better. This is negative x, y. All the points in quadrant 3 are negative x, negative y. Now notice, this is where cosine is negative. Cosine is the x values. Cosine's negative on both of these. But tangent is sine over cosine, or y over x. So if I do negative y over negative x, that's positive. But y over negative x comes out to be negative. So quadrant 2 is where a negative tangent occurs. So what is the value of sine in quadrant 2? Well, the value of sine, if you look right here, is positive. So that's why we choose the positive version instead of the negative version. Had tangent been greater than 0, we would have chosen the negative version because it would have been in quadrant 3 instead of quadrant 2. So it's all sorts of little details you have to pay close attention to there, okay? So now that we know this, we know what cosine is. Cosine is negative 4 over the square root of 17 squared, because this is cosine squared, remember. Cosine squared x. So that's negative 4 over the square root of 17 squared. So punch that out in your calculator, and you should get the square root of 1 over 17, which equals 1 over the square root of 17. And I'll take this answer, or if you want to rationalize the denominator, I'll also take this answer. There's no need in you having to rationalize it, but I'll take either answer. So that would be sine. So we know that sine now is 1 over the square root of 17. Well, because of that, we know what cosecant is. That's the square root of 17 over 1, which is just the square root of 17. Now, because we know sine and cosine now, we can find tangent. Tangent, remember, is sine over cosine. So that's 1 over the square root of 17 divided by negative 4 over the square root of 17. So if we do the reciprocal like you've always been taught to do, you get, well, this should be a multiplication sign right here, folks. That should be square root of 17 over negative 4. And notice that the square roots of 17 will cancel each other out. And so we're left with negative 1/4 for our answer for tangent. Okay, well, what is cotangent then? Cotangent x. Don't forget to write your x. I've forgotten that twice already. Forgot it right there, and I forgot it right here. Okay, cotangent x is the reciprocal of tangent, so that's just going to be negative 4. Okay, negative 4. So we found all 6 trig functions. Using another identity, we just used the Pythagorean identity this time. Okay, so this is the first video. I'm splitting it up like this because these were a couple of application problems. The next video will contain all verifications, and verifications are the most important part of this. Okay, so see you in the next video.